So in this course I am going to cover the welding processes, and I am not going to discuss any metallurgy. There won't be any metallurgy, okay, no microstructures, no phase transmissions. So I will talk about the physics of welding processes. So the physics behind the heat generation and the heat source generation, the reaction, okay. So what mechanism we generate heat and the pressure, or both heat and pressure, okay. That is what we are going to talk about it. So I will just show you the syllabus what we are going to cover. So we divided into 7 chapters this course when we designed this course, welding process course, okay. We are going to cover the entire spectrum of the welding processes that are commonly used for engineering applications, okay. So first we look at the classifications of the welding processes based on various the methodology we can classify the welding processes, and we will also look at the heat source, the principles behind the heat generation. So one of the very common, most widely used welding process is arc welding process, okay. And we are going to understand, so what is arc, how we generate heat in the arc. So what is that actually happening inside the arc that generates heat, and we look at all the fundamental governing principles, okay. So what are the reactions that are happening inside the arc, okay. So what are the rate controlling factors that can be influencing the heat generation in the arc. So that is the first chapter. We will understand the physics behind the arc, okay. So then we will move on to the actual processes. Then we will use that arc, and we can strike an arc by various ways, okay. So we can use non-consumable electrode or consumable electrode, or we can also use a plasma as well to generate heat. So we will move on to the each processes in unit by unit. The first unit, physics of arc, we understand the physics of arc. Then we will move on to the second unit, where we look about we study about the gas tungsten arc welding, okay, and then principles behind the gas tungsten arc welding and the application of this process, and what are the rate controlling factors, what are the parameters which are going to affect the process stability, and so on and so forth. And then the after second unit, third unit is on a consumable welding process. So in gas tungsten arc welding, the tungsten electrode is not molten, whereas we can also strike an arc with a consumable electrode. So that process are known as gas metal arc welding, or manual metal arc welding, or Schilder metal arc welding, okay. And we look at the variants of this process, and in this process of consumable welding, we also transfer the molten consumable onto the weld pool or material, okay. So we will also see how the process characteristic can change the metal transfer characteristics, okay, metal transfer behavior. Again, the principle behind, what are the forces acting on a droplet when it detaches from the tip of the electrode, how we can manipulate the force so that we can change the shape of the droplet, okay. And then how we can increase the productivity, for example, by varying the parameters of welding, and what are the optimum transfer characteristics to achieve a best weld. So we are going to look at in third chapter about all these physics behind and the consumable welding processes, okay. And then fourth chapter is on power sources. So it's also very important, because we use a power source to generate and current as well as the voltage, and we also regulate these current and voltages for our own benefit, so that we can stabilize the process. So we need to understand what is there inside the power source. So the power sources generate the parameters, the heat generating parameters, mainly the current and voltage, and of course we have a lot of modification to current power source, and we can have a small computer inside the power source, so that all the parameters which are all important can be regulated. So we look at a typical welding power source and the characteristic of a power source from early 50s to the modern power sources, which can have an inbuilt microprocessor and synergically controlling the welding parameters which are actually used for welding, okay. So upon looking at all this the background, we will also move to the other welding processes, for example resistance welding, where we do not use arc, okay. So arc, like in the gas tungsten arc or gas metal arc, but we will use Joule heating. Okay, so what is Joule heating again? So when the current is passed on a conductor, you get heated up, right? Okay, so Joule heating. So we will use Joule heating mechanism to weld two material. Okay, so there are very commonly used welding processes that uses Joule heating. It's also known as resistance welding. Okay, so there are variants of resistance welding: resistance part, resistance seam, and projection welding, for example, or flash bed welding, resistant upset welding, okay, percussion welding, and how these, again, the physics govern the heat generation in this process, right, and how we can modify the parameters to achieve best weld. So that's what we are going to look at in chapter 5. And then chapter 6 about the processes which are very close to my heart. Okay, so I have been working on these processes on laser welding as well as electron beam welding. Again, so laser is also can be used as a heat source, same as electron beam, right? But again, it is not like in arc welding, so where you can manipulate current and voltage. Laser welding, it has its own characteristics, the power, distribution of power in the beam, and again we need to understand the physics behind the optics, the laser optics, to control, to manipulate the welding parameters. Okay, and we will look at again the physics behind the laser welding and electron beam welding, some of the important factors that govern the stability of the process. We look at the forces again acting on these welding processes, how those forces are balanced when you are using these welding processes. So we will understand their governing mechanisms in achieving a good stable weld. Okay, and then last chapter we will move on to the solid state welding process, where we don't really heat it up as high as you do it in arc welding or laser welding or resistance part welding, and you do it at a solid state, slightly elevated temperature, but not involving a liquid or melting. Okay, so there are various processes that are getting commercialized nowadays in a solid state welding. So for example, friction welding, friction stir welding, okay, and ultrasonic welding and explosive welding. For example, it's been there for quite some time. It's still, the commercial application is still limited, and we can also look at resistant diffusion bonding and adhesive bonding. So this is the overview of the syllabus we are going to look at in this chapter. As I said, no microstructure, no phase transmission, no metallurgy, right? So this course is designed to give fundamentals about the welding process, and this is very basic. Suppose if you are even employed in some company, and if a company uses a welding process, and you want to look at how the process works and what are the physics behind it. Unless you understand the fundamental physics correct, you can't manipulate, you can't derive the advantage out of this process. Okay, so that is the objective of this course. The learning outcome is, given a welding process, you need to understand, so what are the principles, physics behind the heat generation or pressure generation, okay, how we can manipulate the parameters such a way that these physics, the governing fundamental can be manipulated, the forces can be balanced to achieve a good weld. So that is the objective of this course. So you need to be able to tell the after attending this course, so what welding process can be suitable for a given application. Okay, because again you need to choose a welding process based on your needs. Unless you understand how a process works, you can't never tell that this process is suitable or not, or if other process is suitable or not. Okay, it's clear, because this is what we are going to talk about it, right? Before going into detail, so I'll also tell the textbooks which I'm going to follow for this course. So the main textbook I'm going to follow is Professor John Nourish book on advanced welding processes. So this book is available in our library, and e-copy is also available, right? So that's the textbook I'm going to use for majority of the chapters, except the last chapter, the solid state welding processes, because John doesn't like anything which doesn't involve liquid. So he never writes anything about solid state welding process. So for solid state welding process, I'll be using the book by Professor Messler, the second one, Principles of Welding. Okay. So, these two are the textbooks I am going to use, right, and for the first chapter, the physics of welding arc. So, that is very extensively covered in the third book on welding technology. Again, the e-copy is available in our library, so you can follow that for the first chapter on physics of welding arc. Okay. So, again, so these are all textbooks I am going to use, and for Lancaster book is also useful for understanding the physics of laser welding and the physics of arc. Okay. So, these four textbooks are already available in our library, and you can choose and then you can refer accordingly. But if you attend the class regularly, you do not need textbooks. You can always use my slides, and if you have any questions, you can always ask me.